So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of vectors with a focus on how to prove points lie on a straight line or that two lines are parallel. Now often when presented with a vector question on a higher GCSE paper, you may get asked to prove or disprove that points lie on a straight line or are parallel. So for example, and it's always good and worth when reading these questions is to make sure that you highlight which parts that we're actually looking at. So with this first one, it says show an AB and DC are parallel. So DC is this length here and AB is this length here. So I want to show that those two lines there are parallel. Now, although they've got arrows, the arrows don't refer to the fact that they are actually parallel. They're just there for the vector purpose, so just the sense of direction. So try not to get too confused about that notation. And then here in the second diagram, it says show A, M and D lie on a straight line. So we want to show that if I draw a line going through each of these 3 points, which I'm going to do now, we want to show that they lie on a straight line. Now the key thing to remember is that on the exam paper, none of these diagrams are ever drawn to scale. So you can't get your protractor out, you can't get your ruler out to show that the things are either parallel or lie on a straight line. So it's really important that you're able to understand that element. So try not to take for granted what they look like, more so what you can prove. Now the way to prove lines are either parallel or that points lie on a straight line is to show that one vector or one resultant vector is a multiple of another. Now this proof applies to both even though they are completely different, but are they? So let's have a look at proving that points lie on a straight line. So in this diagram, if I just highlight, now I know I've drawn these on a set of axes, but it's just to make the sort of connection a little bit easier. So if I look at A, B, C and I want to show that they are on a straight line. Now B is somewhere in between A and C. It doesn't really matter whereabouts it is. But the key thing to remember is that if I was to work out the gradient of AB, then regardless of the numbers, so for example, if let's say that was 4 and that was 2 and this was 8 and that was 4, then the gradient between AB will be the same and the gradient of BC will be the same. So here, if I just said that the gradient here of gradient of AB is 4 over 2, which is 2, and then I worked out the gradient of BC, which is 8 over 4, which is also 2, you can see that they've both got the same gradients. However, the calculations are using different numbers. So basically to get from this calculation to that calculation, all I've got to do is multiply both numbers by 2. Now if I look at two parallel lines, now again, if I'd label this as AB and I label this line as CD, you can see that the line CD is smaller than AB, but here they've both got the exact same gradient. So the gradients are going to be the same even though the numbers are going to be different. So if this was, let's say 10 and that was, let's say 6, then this gradient here, if they are going to be parallel, it's going to have the same gradient, but it's just going to be using smaller numbers. So that's going to be 5 and that's going to be 3. So here the gradient of AB is 10 over 6, which is 5 over 3, and the gradient of CD is 5 over 3, which is just 5 over 3. So in other words, to get from, let's say, this gradient to this gradient, all I need to do here is multiply by half or divide by 2, whichever is your preference. So the key thing to remember is that one is going to be a multiple of the other, and this here is the multiple, is that if we multiply both numbers by, and we're going to be looking at multiplying, but if you multiply one by the other, then they should be multiples of each other. Now you may be asking, well, how do I know the difference? If I'm using the same proof for showing that lines are either parallel or showing that points are lie in a straight line, how is the proof different and how do you know that one is different to the other? Well, the difference is in the notation. So if I wanted to go on to prove that 3 points lie on a straight line, then here I'm looking at this resultant vector of A to B, and I'm showing that there is a common multiple between B to C. And you can see here that when we're proving that 3 points lie on a straight line, that we're going to have a common letter. So here our common letter is B. And then if we look at proving that lines are parallel, we can see in this first sort of resultant vector that this vector here is going to be AB and this vector is CD, and you can see here that in each of those two sets of resultant vectors there is no repeated letter, so there's no common point between those two vectors. So therefore, if we show that one is a multiple of the other, it's going to be proving that the lines are parallel rather than they're lying on a straight line, because there is no common letter. So now let's have a look at to check to see if expressions are multiples of another. So let's have a look at this first one here. So let's just start by numbering these questions first. And so let's say we've worked out the vectors between one point to another, and these are the vectors in terms of A and B, and we want to show that either they lie on a straight line or that they are parallel, and to work out what the common factor multiple is if there is one. So looking at A, B and to B to C, so we can see here that to get from this to here, now I probably could do with having a space between them, so let me just put a space between each of these because it's going to be a little bit handy when explaining. And let me just get rid of that arrow. So for this, we want to see what the common ratio is. Now, it doesn't really matter what order you go for. You can have the smallest at the top or the biggest at the top. It's entirely up to you. It really does depend. But you tend to find that as we're dealing with multiples, we are looking at multiplying rather than dividing. So I would probably opt for having the smaller one at the top and the big one at the bottom. But again, it doesn't really matter what order you do it in. So to get from looking at the A's, well, to get from 2 to 4, I've got to times by 2. And to get from 5 to 10, I've also got to multiply by 2. So as you can see, that because these multiples are the same, that if I double AB, that's going to give me BC, and that is the notation. Now you might be asking, well, have I showed that ABC lie on a straight line, or have I showed that AB is parallel to BC? Well, in this particular question, because we've got a common point, then it means that this is going to be a straight line proof. So what I would say is that A, B and C lie on a straight line because, and then this would be your reason, because 2 lots of AB would equal BC. So moving on to question 2. So again, looking at the common multiples. So I see that this one is smaller, so I'm going to go from here to here. So here I'm going to be multiplying by 3, and here I'm also going to be multiplying by 3, and you can see that these numbers here are the same. So here we've got, now looking at the letters, you can see that I've got 4 unique letters, so therefore DE is parallel to GH, and the reason for that is because if I multiply 3 lots of GH, it equals DE. So this is the mathematical statement, and this here is the evidence. Moving on to question 3. So how do I get from 10 to 5? Well, here I'm going to multiply by minus a half because I've got a change in sign. And here I multiply by, again, minus a half. And if you're ever unsure, you could always do it on the calculator. But you can see here that these two numbers here are the same. So looking at the letters, we've got a common letter. So E, F and G lie on a straight line. And then the reason for that is because a half of FG equals EF. Alternatively, what you could say, or 2 lots of EF equals FG, and it really doesn't matter which one you prefer because they both mean the same thing. So then moving on to question 4, so looking at this, well, going from AB, so looking at this, we've got multiplied by 2, but here we're multiplying by 3. So you can see here that these numbers are not the same, so therefore they're just random points. So neither are parallel or lie on a straight line. Now because there's no common letter, it's going to be the fact that they're not parallel. So this statement here is kind of pointless. And then moving on to the last one. So again, with this, it might seem a little bit confusing, but with doing higher GCSE, you could expect things like this. So just be brave and pick one direction. So for this, let's have a look at doing from 6 to that. So what do I have to multiply? -6 to get -1/3. So here it's going to be 6 divided by 3/5 or -3/5. And I get an answer of -10. So if I multiply that by -10, there's my common factor. And so it's going to be the other way around. So if I go from here to here, it's going to be times -10. And if I then do positive 20 over 3 divided by -2 over 3, I get an answer of -10 again. So here you can see that because these numbers are the same, and looking at this, we've got no common letter, so AP is parallel to BN as, and then looking at this, I've got -10 AP is equal to BN. Alternatively, what you could write is that AP equals -1/10 of BN. That's a 10 there. So that's the way that you would prove it. And so working with these answers. Now, how do we get these answers? Well, that's just using and calculating resultant forces from a diagram. So let's have a look at an example. So it says here that in the diagram OA, and let's do some arrows. It doesn't really matter, but we can make out what they are. And you might find that sometimes in a question it may give you the arrows, sometimes the letters are underlined, but try not to be too distracted if they're not. So looking at this question, it says in the diagram OA, to be fair, it's even messier now, so let me just get rid of those arrows and I'll make do with what they are. So from this it says OA is A, which none of this diagram is labelled, so let's label it. So O to A is A. And it says O to B is B. And it says OC is the same as CA, so it's a midpoint. So this is going to be here. So this line here is going to be a half A. And that line there is also going to be a half A. And OB is equal to BE. So if this is B, then this is also going to be B. And it says that BD to DA is in the ratio of 1 to 2. So the question is asking us to work out what B to A is. So let's first of all work out what B to A is. So B to A is starting at B and it's going to A. So if I just write down question A here, it's looking at AI. So B to A. So to B to A, it's going to be minus B because I'm going against the arrow, and then it's going to be plus 1A. So I don't know why I've written B there, so let me just change that. So minus B plus A, and there is my final answer, or I could write it as A minus B. So then looking at part 2, it then says work out B to D. So B to D is going there. Now what I'm going to have to use this ratio. So I'm going to be splitting the ratio of B to A. So if B to A equals A minus B, and that equals 3 parts. So then one part is going to be 1/3 of A minus 1/3 of B. So B to D is 1 part. So B to D is going to be 1 part. So this distance here is going to be minus 1/3 A minus 1/3 B. And D to A, which is this length here, is going to be 2 parts. So there is my answer for part 2. And just for a bonus, D to A is going to be 2/3 A minus 2/3 B. And that's, I'm just going to write that down just in case I need it for another part of a question. So then moving on to part 3, it says C to D. So C to D is there. So I'm going to go from C to D, I'm going to go C to A, and then A to D. So C to A is a half A. And then I'm going against the arrow, so I'm going to take away 2/3 of A plus 2/3 of B. Then combining these two things together, so what's 0.5, take away 2/3, and that gives me a 6. So it's minus 1/6 A plus 2/3B. And then for part 4, it's asking for CE, so let me just put that over there. And C to E, so C to E, I'm going to go from C to O, and then O to B, and then B to E. I could just do it in one straight line, but that's absolutely fine. So C to O is minus a half A, and then I've got plus B, which gives me a final answer of a half A plus 2B. And there we go. Now the next one in terms of B, it says explain why points C, D and E lie on a straight line. So for this, what I want to do is I want to first of all work out what C to D is, which is our answer in part 3. So that's minus a 6th A plus 2/3 B. And I then want to work out D to E, which I haven't worked out, so let's work that out. So D to E is going to be equal to D to B and then B to E. So D to B is going against the arrow, so that's minus a 1/3 A plus a 1/3 B, and then I'm adding B, which gives me, if I simplify all of that, I get minus a 1/3 A plus 4/3B. So these two things here are what I want to show explain why it's in a straight line. So as you can see, to get from one to the other, well, if I multiplied both of these two things by 2, so if I times that by 2, I would get the same thing. So here, what I'm going to show then is, if I make some space, so let's just get rid of part this. Hopefully you've made a note of it. So in terms of part B, we can see that if C to D is minus 1/6 A plus 2/3 B, and D to E is equal to minus a 1/3 A plus 4/3 B, that as two lots of and ADE equals CD, then C, D and E lie on a straight line. And there we go. So now let's have a look at another example. So in this question it says, given OA equals 2x plus 9y, O to B equals 4x plus 8y, and C to D equals 4x minus 2y, explain the geometric relationship between the straight lines of A, B and CD. Now looking at this is related to vectors, it's either going to be proving that they lie on a straight line or that they are parallel. Now as you can see, with A, B and CD there is no common letter, so it's going to be a case of proving that they are parallel or not parallel. So let's have a look at what we know from this. Now we've not been given any diagram. Now O is usually a starting point. So if I just have this as a starting point and I draw a line, and let's just call this point A, that to get from O to A, that vector there is 2x plus 9y. And again, this is just completely fictitious. I'm completely making this up. And we also know that O to B, so if I draw another line and call this point B, that this vector is 4x plus 8y. And we've got this rogue point of C to D. So if I just put that there, C and D, and that's 4x minus 2y. So let's first of all have a look at the vector that joins A to B. Well, A to B is going to go from A to O and then O to B. So O to A is going to go against the arrow, so it's going to be minus 2x minus 9y. And O to B is going with the arrow, so it's going to be plus 4x plus 8y. And if I collect all the like terms, I get a value that A to B is going to equal 2x minus 1y. So let's just put a little box around that. Now I know that I've got C to D, which is 4x plus 2y. So if I just write them out again, so I've got 4x minus 2y, and I've got A to B, let's just stick some arrows there, equals 2x minus y. Well, to get from this to this, I've got to multiply by positive 2. And to get from this to this, I've also got to multiply by positive 2. So looking at this, I need two lots of AB. So as 2AB equals CD, then AB and CD are parallel. And there is our answer for that question. Then moving on to question 3, it says that ABCD is a parallelogram. M is the midpoint of CB, N is the midpoint of AB. It says D to A is A and D to C is C, which has been labelled on the diagram for us. So for part A, it says find in terms of A and C the vector from M to N. So let's first of all make a note of this. So we know that these are halfway. So this length here is going to be a half C, and this length here is also going to be a half C. And we know that M to B is going to be a half A, and C to M is also going to be a half A. So to get from M to N, the route I'm going to choose is I'm going to go from M to B and then B to N. So looking at M to B, well, that's going to be going with the arrow, so that's going to be a half A. And then go from B to N, that's going against the arrow, so that's going to be minus a half C. And there is my final answer for that one. Then moving on to B, it says show that CA is parallel to MN. Now with these, it's always good practice to highlight what it is we're working on. So here we've got A to CA, which is this line here, which I'm going to have to draw again because that is the worst line ever drawn. Well, maybe not the worst. So if I just draw that line there, and that's C to A, and I then want to draw another line, let me just change the colour of that, from M to N. So I want to show that these two lines here are parallel. Now in order to work them out, I need to work out what the resultant vectors for each of those lines are going to be. So here C to A is going to be, again using the diagram, going against the arrow from C to D, so that's going to be minus C, and then I'm going with the arrow, so that's going to be plus A. Then going from M to N, which I've already worked out, which is a half A minus a half C. Now with this first one, I'm going to swap these two things around. So I'm going to write that as plus A minus C. So we're going to write that's A minus C. And from this you can see now what I'm going to do is just think to myself, well, how do I get from one to the other? So here I can either go in this direction, so I can go from there to there. So to get from half to 1, I need to multiply by 2. And again, from half to 1, I need to multiply by 2. So here, as two lots of MN equals CA, CA and MN are parallel. And it's really important that with any types of proof question, you always state your mathematical statement, which is that they're parallel, and then you've also got to state down the evidence. Now this in itself might be good enough evidence, but generally you do need to show in your working out this as well, because you need this, that green bubble, to prove that orange bubble, and to then quantify the statement. Then moving on to question 4, it says R, S, Q and P are midpoints of OC, CB, BA and OA respectively. And it says O to R is equal to A, C to S is equal to B and O to P is equal to C, which is labelled on the diagram. And the question is asking us to show that RS is parallel to PQ. So let's first of all highlight the two lines in question. So RS is this line here going in this direction, and we're looking at PQ, which is this line here going in that direction. Now, when proving things are parallel, it doesn't really matter which direction each is going. So QP is the same as that vector. I'm still showing that the two lines are parallel, so it doesn't matter the order in which the letters in terms of your proof, but sometimes it's kind of easier not to mess around with positive and negatives. So let's have a look at working out each of those values first. So to get from R to S first, so R to S, so R to S, well, that's going to be, well, looking at the midpoints, well, if O to R is equal to A, then this here is also going to be, let me use a different colour, so this length here is also going to be A. We know that using the midpoints, I'm just labelling things across, that's also going to be B. This length here is also going to be C as well. So R to S is going to be going from R to C and then C to S. So R to C is going with the arrow, which is A, and C to S is going with the arrow, so that's B. So there is my RS. Then working out P to Q, well, P to Q, I'm going to go from, well, let's have a look at going from this first. Now, is there any mention of Q? Q is the midpoint. So now for Q, what I need to do is I'm going to go, the route I'm going to go is I'm going to go P to A and then A to Q. Now with this question here, well, P to A is just C. Now for A to Q, I need to work out what that's going to be equal to, a half of A to B. Now A to B is going to be minus 2C. Oh, don't know what I've written A for. So that's going to be minus 2C because I'm going in this direction. And then I'm going to go in this direction, which is 2A. And then I'm going to go up, which is 2B. Now, half, if I divide all of that by 2, and I can't simplify because that's all it is, so I divide that by 2, so half AB is going to be minus C plus A plus B. In other words, A plus B minus C. So that is the length of A to Q. So then if I then swap this for this, what I've got is that P to Q is going to be equal to C plus A plus B minus C. And if I simplify all of this, I'm left with A plus B. So here, as RS equals PQ, RS and PQ are parallel, because as you can see that this here is the same as that there. And then moving on to our last example. So this example here says, is BCD a straight line? Show your working to support your answer. So let's first of all have a look at the points. So we want to show that these 3 points on a straight line. Well, let's first of all work out B to C. Well, B to C is going to go from B to A and then A to C. So that's going to be going with the arrow, so it's 5A minus 2B. Then I'm going against the arrow, so it's minus 3A minus B. And that gives me an answer of 2A minus 3B. And the next thing for me to then work out is what D to C is. C to D is rather. So I'm going to go from C to A and then A to D. So C to A is going with the arrow, so that's 3A plus B. And then A to D is going with the arrow again, so that's 3A minus 10B. And if I simplify the expression, I get 6a minus 9b. So then if I just write it a little bit neater, so I've got b to c is equal to 2a minus 3b, and I've got c to d, which is 6a minus 9b. And I try to then think of what the common multiplier is going to be. Well, to get from 6a to 3, I need to multiply by 3, and 9 to b, I multiply by 3. So here, as 3 lots of BC is equal to DC, then B, C, and D lie on a straight line. And there is my final answer.